Hi. So in this video, we are going to talk about Gaussian surface and its properties. This topic is supposed to be present by Semjas, but yeah, she's not here, so I'll take up this one, but I will give some other topic to her. Okay. What is exactly a Gaussian surface? For example, we have seen different charge configurations. So at present, let us take charge configuration like this. When we have a positive charge, we know that the lines of force, isn't it? We are not calling as field lines. Make sure that you are also not using that term. The lines of force are going away from the positive charge. If it is a negative charge, we know that the lines of force will be towards radially inward. We use this term, right? Here, whatever my screen, whatever the video in which you are watching the screen is a plane surface. That's why you can just see here. But actually, you need to imagine a charge kept in space in front of your eyes. If you keep, the field lines will be moving throughout the space. Yeah. So when you decided that you want to enclose this charge, let me use the color red. Okay, and say that I will try to enclose this charge with some kind of, okay, here I am drawing I'm drawing original thing here like a surface. I'm drawing a surface. If you observe, it's not anywhere open, it's a closed surface. And the purpose of me drawing, even I can draw another surface here as well. Just give me a minute. I can draw another surface here. Okay. So basically, the Gaussian surface is a closed surface which is enclosing the charge. Okay, it is a closed surface enclosing the charge. It can be imaginary also. You can just imagine, because when you have a charge in front of you, you can't simply draw something. You can just imagine that okay, there is a surface which is enclosing. How does it gonna help us? One can see from the magnitude of the electric field because of the field lines. If you calculate here at this moment, here at this moment, because it's a sphere which is enclosing your charge, from the charge, assuming that the charge is at the center of the sphere, at any point on the surface of the sphere, you will get the electric field as same, isn't it? You will get the constant magnitude. So it helps basically to calculate the electric flux. In turn, you can also calculate the electric field at a point. Okay. So Gaussian surface, you can say it's an imaginary or hypothetical closed surface which encloses the charge, with which one can able to calculate the electric field or electric flux, you can say. Okay. So this is about the Gaussian surface. I would like also to share in terms of properties. Let me erase them. Okay. Let us start one by one. The first property says that whatever we have drawn, okay, whatever we have drawn till now, the first one, that is a closed surface, isn't it? The Gaussian surface which we have drawn is a closed surface. Why are we drawing? We are making sure that where exactly we need to calculate, whether it is inside the surface or outside the surface or on the surface. That's why there's the property of first property is that the surface which you are choosing, it has to be a closed surface. Okay. The second one, whenever you choose to draw a Gaussian surface, okay, and you will be given, for example, say that I have a charge here, okay, say that I have a plus charge here, and you choose to draw your, what to say, Gaussian surface. Yeah, you choose to draw your this is another issue. Yeah. So whenever you choose to draw a Gaussian surface which is enclosing our charge, and now I would like to calculate the electric field. I would like to calculate the electric field at this point. Say, or else at this point. I can't simply draw a Gaussian surface here. So I should make sure that my Gaussian surface has to pass through that point as well. Making symmetrical, that's it. Okay. Can you see, did you understand the second point? That whatever the surface you are choosing to draw, okay. Whatever the surface one choosing to draw, that surface it has to pass through the point where you are intending to calculate the electric field. This is the second property of the Gaussian surface. I hope the things are getting clear. If you have anything, feel free to write to me. Okay. Then let me clear the drawings and let me move to the next property, that is the last property, saying that whatever the so it says that whatever the surface you are choosing, okay, it has to have the symmetry of the source. So for example, just before we have drawn, isn't it, just before we have drawn that, or else let us take in this yeah, the same charge Q, single charge if you take, okay, you have to choose your Gaussian surface in such a way that, okay, it has to follow the symmetry of the source. When I say it has to follow the symmetry, it means to say that whatever the field lines are passing, they have to pass through the surface in such a way that, please look here, the next line, the field is normal to the surface at each point. How is it possible? Okay, let us say that choose a field line, okay, choose a field line because of this charge. Let me take this one, which will be easy for me. Okay, the field lines will be like this. So I can select some patch here. Let me take some other color. Let me select some patch here, some surface, and if I draw my vector, that is the area vector. This is my area vector. This is white color is electric field lines. Okay, so my area vector and my field lines are in the same direction, such that the theta between them is equals to 0. So we have to choose, because when it becomes theta is equals to 0, one can easily find the flux. That's what I mean to say. That one has to choose their Gaussian surface, which has to follow the symmetry of the source. For example, here I have taken a single charge in space, means that whole of the line should be passing through in the space, and when you encloses with the help of a sphere, all the field lines will pass through the Gaussian surface. For example, if I take a line charge, say that I had a line on which charges are arranged uniformly. Let me take the positive charge, that is easy for me to draw. Say that positive charge I have, simply you can keep plus charge. So when you have something like that, you know, right, the field lines pass through like this. Should be spaced equally. Yeah, even in this case, I'm taking a line charge, the field lines are like this. Now I should be very careful, because I can't take my sphere, okay, I can't take a sphere to enclose this charge. So I had to choose a Gaussian surface which will help me to enclose all these field lines. The line charge is in space, kept in space. So the field lines will pass through everywhere. Here only I'm drawing on a plane. Okay, even on the back side it will be there, even in this cross side it will be there. Okay. So what I will do is I will take a cylinder. I'll take a cylinder which has the symmetry of this source, such that all the field lines will pass through. Okay. So in that way, I have not drawn a cylinder here. The cylinder becomes this particular part. This is my Gaussian surface here. Okay, this sphere whichever I have drawn. People say G surface. That term they use in bachelors, so you don't use. You just say Gaussian surface. Even here also one can draw a cylinder. Let me draw a cylinder. Imagine you have a pen and kept in a cylinder. You can see that all the field lines coming, all the lines of forces coming from the line charge will pass through the Gaussian surface. This is our Gaussian surface, the blue one here. This is our Gaussian surface. So all these are the properties of Gaussian surface. Now, with the help of this, we will be trying to look at the applications of Gauss law in next video. Okay, so I just want to share one small numerical because which I forgot to share at the last class. That is only one numerical. I have given the answer here at the end. You can see they have given. I'll give few hints so you can just figure out how to calculate. They have given you a charge, okay, which they are saying they kept it sphere and they have given the radius is 0.5. They are asking not to simply calculate the flux, but something called flux density. So how will you get flux density? So flux density, I'm sorry, which is nothing but whatever the electric flux you have, okay, whatever the electric flux you have upon area. But how will you calculate the flux? This flux, you use Gauss theorem. Yeah, that is Gauss theorem. Phi E tells the total net charge enclosed times 1 by epsilon times. So you have epsilon value. You have the Q has given to you. So find out phi E, then keep here area, find out the area of a sphere, then substitute. We will obtain this value. Okay, so I'll stop here.